So there were questions on 1/6, and then on the back, 12, 13, 14, 15. Okay? So 1 and 6, luckily, are just a single transformation. This particular one, it's inside the function, so it's horizontal. It's a plus or minus, so it's a shift. And it's specifically -2, which means right 2. So every critical point, and they kind of have 3 of them there, are just going to move right 2. Be careful of your spacing. This is 2 unit, or this is 2. It's only 1 unit because they're counting by 2, so just be careful of the scale. This moving 2 right goes there, this moving 2 right goes there. That just, if it's already pre-scaled for you, just make sure you're careful to use the scale that they provided. If I look at 6, just quickly getting into it, these are counting by 1s, so just so we're aware. This is a negative sign within the function, so it's horizontal. It's a negative, so it's reflection. And that means always a horizontal reflection is like over the y-axis. So this one's interesting because that point's right on the y-axis, so when you reflect it over the y-axis, it stays put. This one is 1 unit to the right, so when you flip it over, it's 1 unit to the left, which is actually where a point already was. And that point that was 1 unit to the left is going to get flipped over 1 unit to the right. So this graph, when you flip it over the y-axis and just do this little thing, it lands on top of itself. So the original graph is right on top of the new graph, and it doesn't really change anything. That's because that vertical line is a line of symmetry anyway, a horizontal line of symmetry. Does that make sense? You can see that? And that happens sometimes with functions. So the image and the pre-image are in exactly the same spot. On the back, 12 and 13 definitely trickier because we get into 2 transformations in one problem. So if we're following order of operations, we always do whatever's within the function first, all that horizontal stuff. If we then finish that, because there's nothing here, we would follow order of operations and multiply by -2. There are technically 2 transformations there. There's a vertical stretch by 2 and a vertical flip. And those 2 can happen in either order, and then the last thing we're going to do is shift up 1. So every point is going to be vertically flipped, stretched by 2, and then shifted up 1. So I'm going to take it 1 point at a time. Here's 0, 0. I'm going to flip it vertically. It's not going to move. I'm going to stretch it vertically by a factor of 2. That's not going to move. When you're right on the x-axis and you're stretching from the x-axis, you don't move. And then shift it up 1, we'll put it here. That's the first point. My second point, a vertical flip is going to put it here. A stretch by 2. Now it's 1 unit below. Stretch that, double that. It's going to be 2 units below after the stretch. And then it's going to shift up 1, so it's going to be right here. Let's go with this point here, and that'll be our last one, and we'll connect them. This one flips, so it's 2 above, flips to 2 below. It's a stretch by 2, so it's already 2 units below. Double that, it's going to be 4 units below. And then shifted up 1 is going to put it right there. So you can definitely see the upside down flip. You can see a little bit that it got a little bit steeper. That's where the stretch is coming in. It's hard to just look at the picture and know that there was a shift up 1 also, but we did do that. So you have every single point has to undergo those transformations in that order. And I think that's the easiest way to do it, is to take it point by point. It's probably easier than taking the whole graph and flipping the whole graph, because then you'd have something just here. And then stretching the whole graph, you'd have something down here. And then shifting the whole graph up 1, you would have 4 different graphs on that one set, which can complicate things. And then this one here, these graphs were not great, but we'll get the idea anyway. The first transformation is shifting right 3 And then vertical compression. I should start this with horizontal shift. Right, 3 vertical compression by a half. So each point in that order moves right 3 and compresses down by a half. So I'll take 1, 2, 3 here. So approximately, we're gonna forget being perfect about the scales here because that's less the idea and they're hard to read. But if I shift right 3, 2, 4, 1, 2, 3, it would go there first, and then compress vertically by a half. So it's going to shrink down by a half. So right now it's approximately at 10. Half of 10 is going to bring us down to, am I reading that right? 2, 4, 6, 8, 10, 12, 14, 16. No, I'm lying. It's at 16. Halfway would be down to 8. So that point really became there. The next point, let's go with this one. Right 3. Approximately there, and then cut it half the distance, which would be approximately there. I can't expect this to be perfect because the graphs aren't legible. Here we are, right 3, cut it in half, so it's 4 units above, half it to 2 units above. And so when you connect these and kind of go with this pattern, that's where we are. It pretty much ended up in the original on the x-axis. So when you shrink that by a half, it's pretty much still going to be on the x-axis. It's going to be hard to differentiate way back here having that. But up here you can kind of see this smush down a bit. And 14 and 15. So these are great multiple choice versions of questions. Sorry, I'm going to try to fix my camera a bit. So a quadratic function has this turning point to start, -3, 7. I mean, if you want to give yourself a visual, that might help some of you. Where does the quadratic function g, defined by this, have a turning point? So you want to think about the transformations and the order. This +4 inside the function tells me that there's first a horizontal. It's a plus, so shift, 4 units left. If I take a point and I move it 4 units left, which coordinate changes, the x or the y? The x. Horizontal stuff only affects your x-axis. Good, Jack. So if I'm taking this and moving it left 4, only my x-coordinate is going to turn into -7, 7. And then after that, the +5 at the end is a vertical, because it's at the end and outside the parentheses. It's a +5, so it's a shift, 5 up. And if you're going up and down, that only affects your now y-coordinate. So picking up where we left off, that y-coordinate of 7 is getting moved up 5, so it'll be -7, 12. So picture this point. Left 4 puts it at -7, 7, and then up 5 puts it at -7, 12. And that's your final answer. And lastly, domain and range. Remember, if horizontal stuff only affects the x-coordinate, then horizontal stuff only affects the domain. Vertical stuff affects the range. So here's an original domain and an original range of your function. What of the following statements will now be correct about the new domain and range after we do this to it? So again, spelling out these transformations, we're within the function. So this first movement is a horizontal shift right 2. Left and right only affects the domain. So if I take this -3 to 9, and we'll use this again. So let's pretend you've got an image that's between -3 and 9. I don't know what it does, but it's between just -3 and 9. And you shift everything right 2. That's just going to move that over a bit. The -3 moved over right 2 becomes -1, and the 9 moved over right 2 becomes 11. And that horizontal shift only affects that domain. This minus 8, which is after the fact, is vertical. That will affect my range. Vertical shift down 8. So if it originally was between 2 and 15 in this range, and we move it down 8, 2 moved down 8 becomes negative 6, and 15 moved down 8 becomes 7. So we have an x between negative 1 and 11, which could be 1 or 3, and a range that's between negative 6 and 7. The answer is 3. So on top of like just being able to visualize and see how graphs transform, we want to understand the fact that horizontal stuff affects the x-coordinates of points and the domains, because that's all x-related stuff, and the vertical transformations affect y-coordinate stuff, like the range. Okay? We're going to spend, obviously, a second day going over this.